Welcome back to the Deep Dive. There's this really profound shift happening in software development right now. It's fundamentally changing how we interact with code. It feels like we're moving beyond just, hammering out lines of code meticulously. It's becoming more collaborative, almost like a new semiotic contract, maybe, between our ideas and these generative machines.
That's a great way to put it. It really is a transformation. We're not just talking about faster tools. It feels like intelligence is being woven right into the development process itself.
Exactly.
And today, we're going to get into two really interesting paradigms that are kind of leading this charge, even though they seem distinct: vibe coding and agentic coding.
Right. And our mission for this deep dive is to really unpack those. Look at their concepts, how they differ technically, what they mean in practice, drawing from the material you've shared with us. We want to see how these are changing everything, from, say, quick prototypes all the way to big enterprise automation, and importantly, what it means for you, the developer listening. So let's start with vibe coding.
Okay.
Andrej Karpathy coined that term, vibe coding, and it's really resonated. It suggests this novel way of working where the programmer is maybe less of a hands-on coder and more like a high-level coordinator. For our audience who really get the weeds of coding, how would you describe its core idea? What does it mean to move past syntax towards intent?
Yeah, that's the heart of it. Vibe coding fundamentally shifts the focus towards intent specification and architectural vision. Instead of sweating the details of every function, you're communicating what you want the vibe, right? Using natural language, maybe diagrams, high-level concepts. The LLM, the large language model, then takes on the heavy lifting of translating that vibe into actual code. It abstracts away the syntactic burden. It changes the interface from rigid commands to something more intuitive. You're almost sculpting the software like a creative director guiding things rather than handcrafting every single piece.
It's not just fire and forget. It sounds like a conversation, an iterative loop. That feels very empowering, offloading the tedious stuff. But what new skills does that demand from developers? If the AI handles the nitty-gritty, what becomes more important for us?
Exactly. It definitely augments our abilities, but it requires a shift in skills. The material points to 5, but 2 really jump out. First is architectural awareness. You, the developer, need to be the strategic guide.
Okay.
You need to steer the LLM towards the right frameworks. Is this a job for React or Node.js or Django? That guidance is key for quality, for maintainability, not just getting something working.
And given that LLMs can sometimes be, unpredictable, I'm guessing version control becomes absolutely critical, like setting save points.
Oh, completely non-negotiable. Using Git frequently isn't just good hygiene anymore. It's essential for creating those checkpoints, those save points. It lets you manage the unexpected outputs and easily roll back if the AI goes off track from the vibe you intended.
Right.
And the second big skill shift is collaborative error resolution. Debugging becomes a team sport with the AI. You provide the context, the error messages, the code snippets, what you expect it to happen, and the LLM helps diagnose and suggest fixes. It's really about effective information sharing and framing the problem strategically.
And tools. You mentioned IDEs.
Yeah, tools like Cursor or Replit, these AI-enhanced IDEs, they really facilitate that tight back-and-forth loop, prompt, response, refine. And this is crucial, the LLM doesn't inherently understand runtime, the execution, the validation. That still usually happens in your standard development environment that you manage.
That's a key distinction. The human managing the runtime defines that vibe coding interaction. But let's push that boundary. What if the AI could manage more, maybe even the whole cycle? That seems to be where agentic coding comes in. How is this different? Is it more than just a copilot?
It's a significant leap, yes. Agentic coding is where you delegate substantial cognitive and operational responsibility to AI agents that are, autonomous, or at least semi-autonomous. Your role shifts dramatically, less copilot, more system-level supervisor or goal setter. The core difference is that these agents can understand and act on high-level, complex goals. Think about Google's Jules agent. The prompt wasn't write this function. It was something like integrate the Google Gemini API into the R1 robot.
Right.
That requires understanding the whole objective across multiple files, maybe multiple systems.
Wow, and it's not just understanding the goal, right? They can actually plan and execute complex steps autonomously.
Absolutely. That's the agentic part. After parsing the goal, they can plan and decompose tasks, break down that big objective, integrate the API into substeps, research the API, design data structures, maybe even figure out a test plan. Then they utilize tools and resources. They can interact with your file system, run compilers, execute test suites, use Git, even browse the web for documentation or APIs. You see this with OpenAI's Codex spinning up sandboxed environments to run code safely.
So they can actually modify code, test it, see if it failed, and try again.
Exactly. They execute and iterate. They can write code, modify existing source, run tests, check the output, log failures, and then iterate, maybe try a different approach. Codex, for instance, can literally run git diff, see the changes, and apply patches automatically. They can even do some reasoning and problem solving, maybe applying heuristics or looking up documentation if they hit an edge case, like Jules adjusting how it parses ATI responses.
That implies they need to remember what they're doing over time for complex tasks.
Yes, another critical piece. They maintain long-term context. They hold on to the session state, manage things like API keys or dependencies across multiple steps, sometimes over extended periods. And maybe the most advanced part is the emerging capability for self-reflection and correction.
How does that work?
Well, some systems can log their own decision-making process, look at failed steps, propose revisions, and retry autonomously. They might present you with a summary like, here's what I tried, here's the diff, here's the execution log.
So architecturally, this sounds fundamentally different.
It has to be. Agentic systems typically embed fully integrated, often containerized runtime environments. Think Docker, WASM, maybe even emulators like QEMU. These are built right into their core operation. This allows them to autonomously generate, execute, test, and refine code all within a controlled sandbox. That's a world away from vibe coding where the runtime is separate.
That architectural point is huge.
What?
Okay, let's really break down the comparison then. Vibe coding versus agentic coding. How does the developer's primary role change between the two?
It's quite distinct. In vibe coding, you're really the director, the co-pilot, the prompter. You're defining smaller tasks, reviewing the AI's output frequently, guiding the details. Think intent architect or maybe creative director.
Right.
But with agentic coding, you step up a level. You become the architect, the project manager, the supervisor. Your focus is on defining those high-level strategic goals and then validating the final outcomes. It's much more of an orchestration mindset.
And that directly ties into the AI's autonomy level, I suppose.
Exactly. Vibe coding. Low to moderate autonomy. The AI is responsive, but it needs constant prompting for the next step. Agentic coding. Moderate to high autonomy. The agent is proactive. It can plan and execute a whole sequence of subtasks with much less step-by-step guidance from you.
Which naturally leads to different ways of interacting. Vibe coding is very conversational, right? Short, frequent feedback loops.
Very iterative. Prompt, check, refine, prompt again. With agentic coding, it's more like goal delegation. You set a complex objective, and the agent works on it, maybe giving you periodic updates or asking for clarification on high-level points, but not constant back and forth.
And we touched on the execution environment. Vibe generates code for your external IDE. You run it. Agentic needs that integrated sandbox.
Absolutely mandated for agentic. It needs robust logging, resource management, security guardrails built in to safely run the code, and tools the agent itself decides to use. This difference really impacts how errors are handled, too.
How so?
In vibe coding, you, the developer, usually spot the errors during your review or testing. You then prompt the AI with the specific error context to get help fixing it. It's a manual, iterative validation process.
Whereas agentic systems aim for more autonomy there.
Right. The goal is more autonomous error detection, maybe using automated tests or static analysis tools within the agent's workflow. The agent might even try to self-correct. Human intervention is usually reserved for the really complex failures that the agent can't resolve, requiring you to look at the logs, assess the situation, maybe guide a rollback.
Okay, and security, that seems like another major dividing line. With vibe coding, you're relying on external tools after the code is generated.
Largely, yes. You'd run your SonarQube or CodeQL scans afterwards, which means there's a risk of things like hard-coded secrets or insecure defaults slipping through in the generated code, and you don't have an automatic audit trail unless you meticulously create one.
But agentic systems are designed differently from the ground up.
That's the key for enterprise use, really. Agentic systems are designed with safety in mind. They often include embedded constraints, explainability features like detailed logging of every action the agent takes, and runtime isolation, things like namespace isolation, resource limits, automatic rollback triggers if tests fail. This architecture makes them inherently more aligned with the kind of reliability and security you need in production.
Okay, given those clear distinctions, let's talk practical applications. For you listening, where does vibe coding really shine? What are the sweet spots?
Vibe coding is fantastic for creative exploration and rapid prototyping. Say you want to quickly mock up a personal portfolio website with React or build an interactive data visualization with something like chart.js. It's about getting ideas out fast, iterating quickly. It's also brilliant for learning new technologies. It acts like a real-time tutor if you're trying to pick up, say, Next.js for a blog, or maybe develop a simple REST API endpoint with Node.js Express. It lets you experiment and see results almost immediately, like sketching with code.
And agentic coding. Sounds like it's geared towards very different scenarios, more structured, high reliability work.
Exactly. Agentic coding excels where you need precision, automation, and scale, often in production or complex enterprise environments. Think about large-scale code-based refactoring, like migrating a huge legacy Python 2 codebase to Python 3. That's a massive, tedious, error-prone job for humans.
Right.
It's also ideal for automating routine engineering tasks, dependency updates across many repos, complex CI/CD pipeline configurations, and critically, things like regression bug fixing. An agent could potentially analyze logs, pinpoint the root cause of a recurring bug, and autonomously generate and test a fix, drastically cutting down resolution time.
What else? Enterprise stuff?
Oh, yeah. Things like automated security auditing against standards like the OWASP Top 10, automatically generating API documentation like OpenAPI specs, performance optimization tasks, or even implementing full end-to-end features like integrating a payment gateway, complete with automated testing and rollback capabilities.
So clearly powerful but distinct. Yet what's fascinating is they don't seem entirely separate. Are we seeing them converge? Hybrid models, maybe?
Absolutely. That convergence is a key trend. They aren't mutually exclusive in the long run. We're already seeing vibe coding tools starting to add execution capabilities, better context management. Replit Ghostwriter doing inline execution is a good example, blurring the lines.
And how are they being adopted? Is it different tracks?
It seems like a dual track right now. Agentic systems are definitely gaining traction in enterprises for those high reliability, mission critical tasks. Cisco using them for testing, Kodiak Robotics for safety verification in autonomous vehicles. Those are serious use cases. Meanwhile, Vibe tools are becoming ubiquitous in education and for individual developers, often integrated right into the IDEs people already use like VS Code or Replit.
Right.
But it's not all smooth sailing.
What are the roadblocks?
There are definitely challenges. Governance is a big one. How do you ensure AI decisions are transparent and accountable? There's understandable skepticism from experienced developers about handing over too much control. And critically, there's a huge need for retraining teams to work effectively in these new AI-centric ways.
So looking at what's the roadmap for agentic AI specifically? How do we build these more capable, trustworthy systems?
Several key directions emerge from the material. A major focus is on architecting trustworthy autonomy. That means designing systems with explainable logs, clear runtime policies, secure sandboxes, and keeping regulatory compliance in mind from the start.
Okay.
Then there's multi-agent collaboration. Imagine specialized agents, one for planning, one for coding, one for testing, all coordinated by an orchestrator agent. That could really help with scalability and complexity.
And memory.
Yeah.
You mentioned context earlier.
Crucial. Memory and context need to improve. Future agents will need better long-term memory, remembering organizational coding standards, past bug histories, to maintain continuity on really complex multi-day tasks. And the human-AI interface needs to evolve beyond just text prompts. Think visual dashboards, real-time diagnostics, better tools for developers to supervise and intervene effectively.
So it comes back to integration.
Ultimately, yes. The future likely lies in strategic integration and hybrid workflow design. Smartly combining the strengths, using vibe coding for that initial creative spark, the rapid ideation, and then perhaps handing off to agentic systems to operationalize, scale, and maintain those ideas in production.
It's really helpful to see the historical arc here, too. AI agents aren't brand new, but they've changed dramatically from those old rule-based systems in the 90s.
Right, like Sherlock.
Yeah.
They were deterministic but couldn't really learn or adapt. Then the 2000s and 2010s brought learning-based agents, reinforcement learning, things like Siri and Alexa Network, adapted to some degree.
But the LLM-powered agents today, AutoGPT, Devin, Codex, feel like a different category altogether.
It's a profound leap in autonomy. These LLM-based agents can do things the earlier ones couldn't dream of. Decompose really abstract goals, synthesize novel code, actually use tools in a dev environment, reason through complex plan-execute feedback loops. That level of contextual awareness and proactive capability, that's what makes this moment feel truly transformative. It's moving AI from just an assistant toward being an autonomous code developer.
So wrapping this up, it's clear vibe coding and agentic coding aren't really opponents. They feel more like complementary pillars shaping the future of how we build software with AI. Vibe coding really leans into that intuition-driven, prompt-based development. It boosts creativity, speeds up iteration, and kind of positions you, the developer, as that intent architect guiding the AI through dialogue.
Exactly. And agentic coding focuses more on automation, structure, reliability. It shifts your role towards being that architect or supervisor, delegating complex goals to autonomous agents that manage the whole lifecycle planning, execution, verification. Both paths really elevate the developer role, moving away from just implementation towards more strategic thinking and oversight.
Yeah. And perhaps the most compelling thought, the thing we want you to really chew on as you navigate this, is this. The future probably isn't about picking one or the other.
Right.
It's likely about mastering the blend, intelligently combining the creative velocity of vibe coding with the structured automation and dependability of agentic systems. That synergy, that's likely what will define the next generation of development and really change how you innovate.